हाँ ठीक है.
Hello students, welcome to IMS Gate Academy excellent practice question series on communication system subject. So earlier we have discussed the various questions regarding the amplitude modulation, DSBSC, SSBSC, etc. And in this particular session we'll discuss one more question regarding SSBSC and then we'll focus on frequency division multiplexing, right? So this particular topic is also common for two branches, EC and instrumentation. So all of you kindly share this video link with all of your friends so that they also will attend this session live and they also will get benefited from this particular session, right? Yeah, this is the first question which is asked in GATE EC in the year 2015 in set 1 for 1 mark. So here first read the question. They have given one signal S of t equal to m of t into cos 2 pi f ct plus m cap of t into sin 2 pi f ct. Here m cap of t is nothing but Hilbert transform of the message signal m of t, and they have mentioned the bandwidth of m of t is very small when compared to the fc signal. Fc means carrier frequency, right? So in general, we know that for a message signal, the maximum frequency that you are having FM, obviously when compared to carrier frequency, this particular frequency is very less. Yes or no? Very less. Okay. So regarding the message signal bandwidth, they have mentioned, so that is very small when compared to carrier frequency, right? Now the signal S of t is A. So here you are having 4 choices. You have to identify the given signal belongs to which choice. Okay. So here in option A it is mentioned high pass signal, option B it is mentioned low pass signal, option C it is mentioned band pass signal, and option D they have mentioned double sideband suppressed carrier signal, right? See, regarding just by looking at this expression, forget about this part. If you are having only this expression like m of t into cos 2 pi f ct, so that means you are having message signal and you are having carrier signal, you are just multiplying. Right? So the product of message signal and carrier signal is nothing but double sideband suppressed carrier. Okay, but here you are having m of t cos 2 pi f ct plus m cap of t sin 2 pi f ct. If you carefully observe, so I am writing the given expression S of t equal to m of t into cos 2 pi f ct plus m cap of t into sin 2 pi f ct. So here you are having message signal m of t. If you are passing through Hilbert transform, if you are passing m of t through Hilbert transform, then you are going to get the signal m cap of t. So when compared to m of t, here you are getting minus 90 degrees phase shift. This Hilbert transform will provide you a phase shift of minus 90 degrees phase shift. Either minus 90 or plus 90 you can consider. Okay. So m of t, if you are passing through Hilbert transform, you are going to get m cap of t. Similarly, here you are having cos 2 pi f ct. Here you are having cos 2 pi f ct. When you are passing through Hilbert transform, so here you will get minus 90 degrees phase shift. So that means cos 2 pi f ct I am considering as it is. Now you have to consider minus 90 degrees phase shift. Minus 90 degrees phase shift. So here you are having cos theta minus 90 format. So from here I am taking minus as common. Okay, I am taking minus as common. Then you will get cos of minus 90 minus 2 pi f ct. Right. So this overall term, if you are considering like theta format, okay, cos of minus theta is nothing but cos theta, because cos function is an even function. Right. So this function now we can write it as cos of 90 degrees minus 2 pi f ct. So cos 90 minus theta is nothing but sin theta. Sin 2 pi f ct. So Hilbert transform of cos 2 pi f ct is nothing but sin 2 pi f ct. Right. So for message signal m of t, after you are passing through Hilbert transform, you are going to get m cap of t. And similarly the carrier signal cos 2 pi f ct, when you are passing through Hilbert transform, you are going to get sin 2 pi f ct. So that means here you are having m of t into cos 2 pi f ct plus m cap of t into sin 2 pi f ct. Right. So if you recall the SSBSC concept, this particular given equation is nothing but your SSBSC signal. Right. So the given m of t signal is nothing but SSBSC signal. Whatever S of t here you are having, the overall time domain equation, whatever you are having, this equation represents SSBSC signal. So here, as the name implies, you are having single sideband. In that there is no carrier component. You are having only one sideband. Right. So Now with this understanding, can you guess among these four choices which one is correct? See, we already eliminated option D, because if you are having only this term, then you can say it is the DSBSC. But you are having in this particular signal, in this particular equation, you are having message signal and the corresponding carrier. Whereas in this particular term, you are having corresponding for both the signals. After you are passing the Hilbert transform, you are going to get. Now, we have identified the given signal is nothing but SSBSC. As the name implies, here we are having one sideband, right? So, say for example, from cutoff frequency to the upper sideband, FC plus FM. Whatever the equation here you are having, this equation represents actually upper sideband. If you want to specify more clearly, this particular given equation represents upper sideband. Okay. Similarly, if you are getting minus here, then it will represent lowest sideband. Okay. So that means on the frequency axis, we are considering from FC to FC plus FM. Similarly, if you are having minus sign, then we will consider FC minus FM to FC, like that. So that means here you are having some band of frequencies. Yes or no? Some band of frequencies we are having. So on the frequency axis, you will be having starting frequency as 0 and you will be having maximum frequency as say infinity. Okay, in between 0 to infinity, we are considering this band of frequencies. FC to FC plus FM. Yes or no? FC to FC plus FM. So that means we are passing, okay, this SSBSC signal is equivalent to with respect to filters. We are passing some band of frequencies. Okay. So here, if you are considering like single tone modulation, then you are getting like FC and FC plus FM. Suppose if it is a multi-tone, okay. So from FC to FC plus FM, whatever the range of frequencies you are having, that range of frequencies we have to pass, right? So that means now you can easily guess the correct answer for this question is option C. Option C is nothing but band pass signal, right? Option A, you are having high pass signal, that is not correct. Option B, you are having low pass signal, that is also not correct. We are passing some band of frequency either from center frequency to the upper cutoff frequency or from lower sideband cutoff frequency to the center frequency or carrier frequency, like that. Okay. So since we are passing only some band of frequencies, that means the given equation represents band pass signal. Okay, I hope it is clear for everyone. So the answer for this question is option C. So this is the question based on SSBSC concept only. Okay, now let us see the questions based on frequency division multiplexing. Yeah, this is the example question. All of you give it a try. Yeah, this is the example question based on frequency division multiplexing. So here you are having 10 signals, the number of signals given 10, and each one band limited to 5 kHz. Each one band limited to 5 kHz are transmitted through a channel simultaneously using frequency division multiplexing. And they have mentioned God band. God band is 2 kHz. And then determine the bandwidth of the multiplexer signal. Okay, here we have to solve this question in 3 cases. If you are using, in case 1, if you are using AM modulators, what will be the bandwidth? Case B, if you are using DSBSC modulator, what will be the bandwidth? Similarly, case C, okay, if you are using SSBSC modulators, what will be the bandwidth? See, in general, the frequency division multiplexing we will use whenever, whatever the number of signals you are having, if all the signals are having the like baseband signals. Okay, whenever you are having baseband signals, right? So it is starting from 0 and maximum frequency you are having, right? So like that, all the frequencies are having the same around some frequencies. Like say for example, here it is mentioned like band limited to 5 kHz. So that means, so here you are having the spectrum starting from 0 and maximum frequency is 5 kHz. Okay, so for all the 10 signals you are having maximum frequency is 5 kHz. Okay, so that means if you want to transmit all the 10 signals directly in the channel, because all the frequencies, all the signals are having the same frequency, right? So what are the information you're having? Now you have to transmit all the signals. Okay, so definitely there will be interference. Just to overcome that problem and in order to effectively utilize the channel, okay, what we can do, we can shift whatever like 10 signals you're having, all the 10 signals maximum frequency is 5 kHz, right? So with the help of any modulator, okay, because in the modulator we are using the message signal and we are using the carrier signal, right? So with the help of modulator, now we are going to shift this particular spectrum. Say for example, if you are considering both negative frequency side and positive frequency side, then here you are having like, you are having like 5 kHz and this is like minus 5 kHz. Okay, if you are considering the spectrum like that. So that means this particular spectrum, magnitude spectrum of each and every signal is centered around 0 frequency. Now all the 10 signals, now we are going to shift are centered around different frequencies. Like suppose first signal we can shift to FC1, second signal we can shift to FC2, like that 10 signal we can shift to FC10. So that what will happen, what is the spectrum here you are having for all the 10 signals, it is initially all are centered around 0 frequency. But now when you are drawing the spectrum for all the 10 signals, okay, you can shift to different frequencies. That means there is no interference from one spectrum to other spectrum like that. Okay, and ideally speaking, like say for example, here this particular signal when you have shifted to FC1, say for example, that time what will happen, say for example this is the 0 frequency, now we have shifted to, this is the center frequency FC1, so FC1 plus 5K and this frequency will be FC1 minus 5K. Okay, say for example here I am considering like this. Okay, right. So here you are going to get the spectrum here. Now what happened? Now what happened? Initially the spectrum was centered around 0, but now we have shifted to FC1. Like that, another spectrum I am considering. Say for example it is centered around FC2. So FC2 plus 5K, FC2 minus 5K. Okay. So like this you can consider 10 signals in this particular example, right? So 10th signal, it is centered around FC10. So FC10 plus 5K, FC10 minus 5K. FC10 minus 5K. So now if you carefully observe, if for the original signal, for the original message signal, okay, so if I ask you to calculate bandwidth, what will be the answer? Here you should not consider bandwidth means from minus 5K to 5K, because always the frequency value should be positive, right? So whenever I ask bandwidth, so you have to consider on the positive frequency axis from where to where the spectrum exists. So the range of frequencies over which the particular spectrum exists, that range of frequencies is nothing but bandwidth. So here on positive frequency axis, it is starting from 0 and maximum frequency you are having 5K. So that means 5K minus 0 is nothing but 5 kilohertz. So this is the bandwidth of the message signal. This is the bandwidth of message signal, right? Now, when you, with the help of any modulator, either AM modulator or DSBSC or SSBSC, okay, so for the time being I have considered whatever the representation here I have considered with respect to AM or DSBSC you can consider, okay. So with respect to DSBSC you can consider, right? So here what happened, you are getting the spectrum, it is getting shifted, right shifted, right? The entire spectrum was got right shift, okay. Now if I ask, okay, forget about the remaining signals, if I ask this particular signal bandwidth, then what will be the answer? Yes. So this is the bandwidth. This is the bandwidth. Yes or no? Here you are having upper maximum frequency and here you are having lower frequency. So if you are taking the difference of these two, from here you are going to get the bandwidth. Okay. So in this case you are getting 2 into 5K. See, FC1 will get cancelled. 5K plus 5K is nothing but 10K. So 2 into 5K, that is nothing but 10K. So here for understanding purpose, I have drawn the spectrum for DSBSC modulator. Okay, DSBSC modulator. Okay, because here you are having upper sideband, you are having lower sideband, right? You are having upper sideband and lower sideband. Okay, now here if you observe, like this, we have to transmit 10 signals. Okay, so here this is the spectrum correspond to first signal, this is the spectrum correspond to second signal, like that this is the spectrum correspond to 10 signal, right? So in between two signals, whatever the unused band of frequencies you are having, okay, between two signals, whatever the unused band, that is nothing but God band. That is nothing but God band. So we will, in general, in all the practical applications, okay, just in order to separate two spectrums, we will provide some band of frequencies. Okay, that band of frequencies is nothing but God band. Okay, so just in order to avoid the interference, okay, due to any signal, etc., or in order to identify the spectrum completely. Okay, so that is the reason we will provide some range of frequencies that is nothing but God band. So in some question they will specify God band value something, in some question they won't specify, or they can say that there is no God band. Okay, if there is no God band means the moment this particular spectrum is ending here, the next spectrum is going to start, like that. Okay, but in this question they have mentioned God band, they have mentioned that is nothing but 2 kHz. Now in this question they have mentioned all the modulators are AM. This is the part 1. Second part, all the modulators are DSBSC, and the third part is all the modulators are SSBSC. So now let us solve with the help of, for every case, let us solve this question. Okay, I hope all of you got the clarity why we are using the frequency division multiplexing. Because initially all the signals are centered around 0 frequency. Now if you observe, while you are transmitting all the 10 signals, each and every signal you are having centered around different frequency. So that means there is no interference or there is no loss of information, right? So you can transmit multiple signals which are initially centered around same frequency, all those signals. Now with the help of frequency division concept, we are able to multiplex multiple signals. Okay, that is the beauty of frequency division multiplexing. Okay, now let us see here. Let us determine the bandwidth of the multiplex signal if all the modulators are AM. Okay, So I hope all of you know the formula regarding the bandwidth of AM signal. Okay, when you are using the message signal and when you are using the carrier signal, there you are going to get. Okay, now let us solve this question in case 1. Case 1, I am considering AM modulators. In AM, you are having the carrier frequency and you are having upper sideband frequency FC plus FM and you are having lower sideband frequency FC minus FM. So among these three frequencies, this is the maximum frequency and this is the minimum frequency, right? So the difference of these two is nothing but bandwidth. So bandwidth of AM, when you are having one signal, I am talking. So FC plus FM minus FC minus FM. So here FC will get cancelled, minus of minus is plus, so you will get 2 times FM. So the bandwidth of AM modulator, you are going to get 2 FM, right? Now in this question, you are having like the 10 signals, okay? So for every signal, they have mentioned it is band limited to 5 kHz. So this 5 kHz is nothing but your FM. 5 kHz is nothing but FM. So that means bandwidth of AM is nothing but according to the given question, 2 into 5K, that is nothing but 10 kHz. Bandwidth of AM is 10 kHz. So that means like this, for every signal you are going to have 10 kHz. Okay, 2 into 5K, that is 10 kHz. Okay, and between two signals, they have used the guard band, that is 2 kHz. Now all of you think and tell me, so guard band, how many times we have to consider? Overall, for transmitting 10 signals, whether we require guard band 9 times or whether we require guard band for 10 times. So all of you think and tell me. So here you are having total 10 signals, right? Total 10 signals are there. For every signal, when you are using AM modulator, you are going to get bandwidth as 10 kHz. So 10 into 10K plus. Now tell me, how many guard bands we have to consider? Yes. So some of you might be telling that 10 guard bands we require. See, say for example, this is the first signal, it is starting from here and 10 signal is going to end here, right? So we are using guard band between two signals only, right? So that means, say for example, between 1 and 2 we require guard band, between 2 and 3 we require guard band, like that between 9 and 10 we require guard band. After 10 we don't require unless otherwise they specify in the question, because our requirement is what? We have to transmit 10 signals. So you just observe only within the 10 signal spectrum. Okay, so when you want to separate one signal from other signal, okay, you just start from the starting frequency and you just observe the ending frequency in between those 10 signals. Just to separate one signal to another signal, you are using the guard band. That's all. So because you are having 10 signals, 10 minus 1 is nothing but 9. 10 minus 1 is nothing but 9, and in the question they have mentioned guard band as 2 kHz. So that means 10 into 10K is nothing but 100K plus 10 minus 1 is 9, 9 into 2, that is 18K. So that means you are going to get 118 kHz. Okay, so this is the answer for case 1 or case A. So I have mentioned like ABC, right? Similarly, if you consider all the modulators are DSBSC, then what will be the answer? All of you give it a try. Yeah. So for DSBSC signal, you will get the frequencies like FC minus FM and FC plus FM. At carrier frequency, you won't get signal spectrum or signal strength, you can say 0. Okay, so here this is the minimum frequency and this is the maximum frequency. So that means bandwidth is nothing but highest frequency minus lowest. So obviously you'll get 2 FM. 2 FM. So if you observe here, you're having carrier frequency in the center, right? When you observe all the 3 frequencies, right? So in the DSBSC, you're going to get the lower sideband frequency and upper sideband frequency. So obviously the bandwidth remains same. Okay, so when you observe AM and DSBSC, so since bandwidth of AM and bandwidth of DSBSC both are same, bandwidth of AM and bandwidth of DSBSC both are same, obviously when you calculate bandwidth of multiplex signal, the same answer you're going to get. Same answer you're going to get. Okay, so directly you can write the answer. Here bandwidth of multiplexed signal. Bandwidth of multiplexed signal is same. That is 118 kHz. 118 kHz. Now all of you give a try with respect to SSBSC. If you are using all the modulators or SSBSC, then what will be the answer? Yeah, in SSBSC, we will use any one sideband. Any one sideband. Say for example, we will use FC to FC plus FM, or we can use FC minus FM to FC. We can use any one sideband. Any one sideband we can use. Okay. So either you are looking here. Say for example, this is the upper sideband. This is the lower sideband. Any one sideband you can consider. What will be the bandwidth? Bandwidth you are going to get FM. It is very simple. Earlier you have considered both the sidebands. So when you have considered both the sidebands, you are getting 2 FM. But now we are considering only one sideband, right? So half of the double sideband bandwidth. So that is nothing but FM, right? So according to the given question, FM is nothing but 5 kHz. FM is nothing but 5 kHz. Now bandwidth of multiplexed signal. Bandwidth of multiplexed signal. So total we are having 10 signals. So for each signal, here in this case 5 kHz bandwidth is sufficient. For every signal 5 kHz bandwidth is sufficient. So regarding number of God bands, it is same. 10 minus 1 is nothing but 9, and God band they have mentioned 2 kilo. So 10 into 5 is 50K plus 9 into 2 is 18K. So 50 plus 18, that is 68 kHz. 68 kHz. So just observe, here we have solved the question in 3 cases. If you are using all the modulators are AM, that time we are going to get 118 kHz. And if you are using all the modulators are DSBSC, that time also we are going to get the same answer, 118 kHz. Now, if you are using all the modulators are SSBSC, that time we are going to get 68 kHz as a bandwidth. Now, just observe these 3, which one you will recommend. If you are supposed to use like AM modulators or DSBSC modulators or SSBSC modulators, suppose if you have got the choice to use any of these 3 modulators, so which one you will recommend? Which one you will prefer? Yes, obviously the last one, because with the help of SSBSC modulator, so the less bandwidth is sufficient for transmitting. Just you can observe here you are getting 118 kHz. Suppose if you are making like round figure 120 kHz, here you are getting 68 kHz. So for the timing, just make it approximate like 60 kHz. Okay, so with the help of this one, like suppose if you are having 120 kHz bandwidth, so there with the help of AM or DSBSC, we can transmit only 10 signals. Okay, but with the help of 120 kHz, okay, just I have considered like approximation. Okay, don't consider it is like exact. Okay, so if you are having same 120 kHz bandwidth, okay, that time here you can able to transmit double, right? Say for example here with the help of 10 signals we are getting 68 kHz. So you can round off to 60 kHz. Otherwise, suppose if you are rounding off to 70 kilohertz, okay, so that means 140 kilohertz if you are having bandwidth, so that means we can transmit 20 signals. Okay, so that much advantage you are going to have. Okay, with the help of same bandwidth, by using SSBSC, you can transmit more number of signals. Or even from the basic definition regarding the bandwidth of any of these modulators, from there also you can easily answer. Okay, in the AM and DSBSC, we are getting twice the bandwidth of, twice the maximum frequency of the message signal, whereas here you are getting simply the message signal frequency, right? So that is the advantage of SSBSC. Okay, so in the earlier modulators concepts we have mentioned, among these three which one is the best one, and even with respect to while you are transmitting multiple signals with the help of multiplexing concept, that time also SSBSC is the recommended one. Now with this understanding, all of you give a try. Yeah, first read the question. You are having 12 signals, each band limited to 5 kHz, are to be transmitted over a single channel by frequency division multiplexing. If SSBSC modulation with the guard band of 1 kHz is used, then the bandwidth of the multiplex signal will be. Okay, similar question only, but in the earlier question we have discussed for 3 cases, right? But in this question it is a special case, or you can say one case of the earlier 3. Okay, the last case, whatever we have discussed with respect to SSBSC. So this question based on that one. Okay. So here, so for SSBSC bandwidth is nothing but FM, bandwidth equal to FM. So here they have mentioned each signal is band limited to 5 kHz. Each signal is band limited to 5 kHz. That means bandwidth of SSBSC modulator is, or SSBSC modulator signal is nothing but 5 kHz. Okay. Now let us determine the bandwidth of multiplexer signal. Bandwidth of multiplexer signal. So here we are having total number of signals are 12. Total number of signals are 12, and for every signal we require this much bandwidth, 5 kHz. And since we are having total number of signals at 12, so the number of God bands required is 12 minus 1. 12 minus 1. And in this question, they have mentioned the God band as 1 kHz. God band as 1 kHz. So here 12 into 5, that means 60 kHz you are getting. Here 12 minus 1 is 11, 11 into 1K, so you are getting 11K. So 60 plus 11, that is 71 kHz. 71 kHz. So that means option C is the correct answer. Option C is the correct answer. Okay, I hope it is clear for everyone. Now let us see the next question. All of you give a try. This is an interesting question. In this particular question, you are having all the three modulators. Like for first signal, they have used AM modulator. For second signal, DSBSC modulator. For third signal, they have used SSBSC modulator. So all of you give a try. Yeah, first read the question. Here you are having three signals, each band limited to 5 kHz, 10 kHz and 10 kHz are transmitted through a channel using frequency division multiplexing. See, here you are having three signals. For the first signal, the maximum frequency is 5 kHz. For second signal, maximum frequency is 10 kHz. Similarly, for third signal, the maximum frequency is 10 kHz. Now, all the three signals, they want to transmit with the help of FDM concept, frequency division multiplexing. And here in this question, they have mentioned guard band as 2 kHz. Now, see the beauty of this question. Determine the bandwidth of the multiplex signal if the modulators used are AM, DSBSC and SSBSC respectively. See, the first question which we have discussed regarding FDM concept in this particular session. In that particular question, we have mentioned that for all the signals, we have considered AM modulators. That is first case. And second case is all the modulators we have considered DSBSC. And third case, we have considered all the modulators are SSBSC. But in this question, it is interesting. Okay. For the first signal, they have considered AM modulator. For second signal, DSBSC modulator. And for third signal, SSBSC modulator. Right. Now, when you consider like this, what is the resultant bandwidth that we require for this multiplex signal? Okay. Right. So here they have given three signals. Like signal 1, signal 2, signal 3. Okay, we are having three signals. For the first signal, they have given maximum frequency 5K, for other two 10K. So here I am considering the maximum frequency of first signal, that is FM1, 5 kHz. Okay, here maximum frequency is 10 kHz. Similarly here, maximum frequency as 10 kHz. 5K, 10K, 10K. Right. Now, here for first signal, they have considered AM modulator. And for second signal, they have considered DSBSC modulator. And for third signal, they have considered SSBSC modulator. Now let us calculate the bandwidth. Bandwidth. For AM signal, it is 2 times maximum frequency. So 2 into 5K is nothing but 10K. Similarly, in DSBSC also bandwidth remains same. That is 2 times maximum frequency. But here maximum frequency value is different. 2 times maximum frequency is 10K. That means 20 kHz. Similarly, for SSBSC, the bandwidth is maximum frequency of the message signal. In this example, maximum frequency is 10K. So that means you will get 10 kHz. 10 kHz. So we calculated with respect to the modulators given, we calculate the bandwidth required for every signal. Okay, right. So now let us calculate the bandwidth of multiplex signal. Bandwidth of multiplex signal. So with respect to first signal, when you have used AM modulator, we require 10 kHz. We require 10 kHz. When you have used for signal 2, DSBSC modulator, that time we require 20 kHz. And similarly, for signal 3, when you have used SSBSC modulator, we require bandwidth of 10 kHz. So like that, whatever the bandwidth, according to the modulator that we have used, whatever we got, we have to consider those bandwidths. Now in the question they have mentioned guard band value as 2 kHz. Now since the total number of signals are 3, 2 guard bands are sufficient. Yes or no? For separating first 2, we require 1 guard band. For separating second and third, we require 1 guard band. Right? So 3 minus 1 into 2 kilo. 3 minus 1 into 2 kilo. Okay. So that means here 10K plus 10K, 20K plus 20K. That means 40K. Next, 3 minus 1 is 2. 2 into 2. That means 2 into 2 is 4. So 40K plus 4K, that is nothing but 44 kilohertz. So this is the bandwidth that is required for transmitting these three signals with the help of frequency division multiplexing when we have considered for first signal AM modulator, for second signal DSPC modulator, and for third signal SSPC modulator, right? So the resultant bandwidth that is required is 44 kHz. So this is the minimum bandwidth that is required. Okay. So the next question, which is asked in GATE instrumentation in the year 2008 for 2 marks. So all of you give a try. Yeah, first read the question. Here you are having 10 real band pass message signals. That means you are having 10 signals. Okay, each of bandwidth 3 kHz. So earlier question they mentioned band limited to, but in this question they mentioned bandwidth. So that means the maximum frequency only. As I mentioned earlier, all the band limited signals, that means baseband signals, you are having starting frequency is 0, and whichever is the maximum frequency, that itself is nothing but bandwidth. Okay, are to be frequency division multiplexed on a band pass channel with bandwidth. So this B kilohertz is nothing but the bandwidth of multiplex signal that we have to calculate. Okay, if the guard band is between any two adjacent signals, should be of 500 Hz, and there is no need to provide any guard band at the edge of the band pass channel. That means after the last signal, you no need to consider guard band, right? So regarding this concept, we already mentioned in the beginning of this particular concept. In the first question itself, we have discussed, right? Okay, so the same assumption. Now they're asking what is the minimum value of B that the value of B you have to consider in such a way that it should be minimum. Okay, the minimum value of B you have to find out. Okay, read the question. The value of B should be at least they are asking. So that means the minimum value of B we have to find out in such a way that there is no loss of information or there is no interference, etc. between any two signals. Okay, so in order to effectively transmit these 10 signals, how much bandwidth we require, minimum bandwidth how much we require, that is a question. So regarding that, you are having 4 choices, you have to choose the correct one. So when you read this particular question, they haven't mentioned what type of modulator we can use, but this last word is giving the hint. This last word is giving a hint that which modulator we have to use. See, earlier we have discussed with the help of AM modulator, with the help of DSBSC, and with the help of SSBSC, right? So when we calculated the resultant bandwidth that is required for AM and DSBSC, both are giving same value, whereas SSBSC is giving different value. And when compared to AM and DSBSC, the bandwidth required in SSBSC modulator is less. Yes or no? So that means now we have to solve this question by considering the modulators or SSBSC. All the modulators we have to use SSBSC, right? So that is the inherent logic. Or instead of straightforwardly mentioning the modulator name, they have given the hint in this way. So once if you are having good knowledge, if you are having basics on about each and every topic, if you are having good command over each and every concept, then only you can solve these type of questions. See, when you look at this question is not at all tough question, but for solving this question, you should have the knowledge of AM, you should have the knowledge of DSBSC, you should have the knowledge of SSBSC. Then only whenever they are framing such kind of logical questions or interesting questions or IQ level questions, that time you can apply whatever the basics that you have learned, you can apply based on the requirement, right? So this is a very interesting question. They haven't mentioned directly that you have to use all the modulators or SSBSC, but they have given the clue here, right? So the clue is SSBSC modulator, because when compared to AM and DSBSC, with the help of SSBSC, you are going to get minimum bandwidth, right? So that is the reason. Okay, I hope it is clear for everyone. So now we are considering SSBSC. So if you want, you can make a note. Among AM, DSBSC and SSBSC, we will get the minimum bandwidth in SSBSC. We will get the minimum bandwidth in SSBSC, right? So in this particular question, you are having 10 signals. Okay, first let us calculate the bandwidth of SSBSC signal. So bandwidth of SSBSC signal is nothing but FM, right? So here they have mentioned the bandwidth of each signal is 3 kHz. 3 kHz. Okay, now let us calculate the bandwidth of multiplexer signal. Bandwidth of multiplexer signal. So according to the question, they have mentioned this is nothing but B. So here you are having, for every signal, bandwidth is 3 kHz. Okay, by using SSBSC, and like that you are having 10 signals. Like that you are having 10 signals. So 10 into 3K. 10 into 3K. And since you are having 10 signals, we have to provide 9 God bands. 9 God bands. Or in other words, you can write 10 minus 1. 10 minus 1. Okay. And God band they have mentioned here 500 Hz. 500 Hz. 500H they have mentioned, right? So here 10 into 3, that is 30K plus 10 minus 1 is 9 into 500. Here you can do multiply and divide with 2. Multiply and divide with 2 so that you will get in the order of kilohertz. Right. So here 30K as it is you can copy. Then 500 into 2 is nothing but 1000. So that one we can write as kilo. 9 by 2 is nothing but 4.5. So that means you are going to get 34.5 kilohertz. 34.5 kilohertz. Okay, so this is the minimum bandwidth that is required when you are transmitting 10 signals. Okay, with the help of SSBSC, this bandwidth required, and this is the minimum bandwidth. And if you want, you can consider 40 kilohertz, 50 kilohertz, 60 kilohertz, more than that. Any value more than that also you can consider. But this is the minimum bandwidth that you have to consider, must and should. Okay. If you are considering suppose 30 kilohertz or 25 kilohertz, so because of that what will happen, you may lose the information, right? You are not transmitting all the signals effectively. Okay. So the final answer for this question is 34.5. So option B is the correct answer. Okay. Option B is the correct answer. So here they have mentioned already this keyword whenever you are having for any particular parameter or quantity, whenever you are having units, you have to focus those units carefully. Here they have mentioned B kilohertz, right? So whatever the B value you got here, you should represent in the order of kilohertz. Sometime in the order of hertz they will ask, sometime in the order of kilohertz, megahertz, etc. So whichever order they have mentioned, accordingly we have to rearrange that particular value. Okay, right. So for this question, option B is the correct answer. So with this, we have discussed variety of questions regarding frequency division multiplexing. So whoever missed the earlier sessions, so kindly visit our IMS Gate Academy YouTube channel. In that you can click on playlist, okay, and you can see regarding the communication system subject, excellent practice question series we have discussed. This is the 9th lecture, right? So total you are having 9 lectures regarding the first chapter, right? Starting from AM, then DSBSC, SSBSC, and then frequency division multiplexing, right? So for all these topics, you will get good command, because in this series of lectures, we have discussed the variety of questions for getting better understanding and deeper understanding, and in not only that, and these questions and concepts will help you for your coming GATE exam as well. And in this series of lectures, we have discussed the variety of practice questions and GATE questions as well. So whoever missed earlier sessions, so kindly watch all these lectures in your free time. And similarly, according to your branch, okay, you can see the respective subjects whichever applicable for your branch. So kindly watch the other subjects also. So we are having the series like excellent practice question series and most expected concept series, etc. Okay. So, and earlier we have discussed like foundation series, etc. So kindly watch according to your branch whichever subjects are applicable. So kindly go through this series of lectures and share these video lectures also with all of your friends, so that they also will go through this series of lectures and will prepare, and it will be helpful for their coming GATE exam. Okay, right. So I hope all of you thoroughly enjoyed and learned a lot regarding the communication system subject regarding the first chapter. Okay, right. So I am going to announce one more coming series from the next week onwards. Regarding communication system subject, okay, we will discuss the important GATE questions which are asked in the earlier years and which are helpful for your coming GATE exam. So I will be coming on live from next week onwards, that is starting from 17th October. Okay, starting from 17th October. So one session we are dedicated for one particular GATE exam year. Like suppose on 17th October, I will discuss the important GATE questions which are asked in GATE 2023 in both EC branch and IN branch. In all the series, in all the sessions, I will discuss the questions which are asked from EC branch and instrumentation branch. Okay. So on 17th October, I will discuss the questions related to GATE 2023. On 18th October, I will discuss the questions which are asked in GATE 2022. And similarly, 19th October, GATE 2021. 26th October GATE 2020 and 27th October GATE 2019. So last 5 years communication system subject questions year wise we will discuss. Okay, and just like here in the earlier excellent practice series, okay, we have discussed variety of questions, but we have more dedicated on the first chapter itself. But in this particular sequence, okay, you will get the command over the entire subject. Okay, whatever the questions which are helpful for you with respect to model or with respect to concept, with respect to formula, anything which are helpful for your coming GATE exam, I will select the questions accordingly which are asked in the respective year, and I will focus each session for a particular year. Like that, you'll be having 5. As of now, we plan for 5 sessions, right? Okay. So all of you kindly share this particular information with all of your friends and kindly do the preparation. Just go through the basic concepts before coming for the live session if possible, and so that whenever I show the question, I will give some time so that you can attempt, you can share your answer in the chat, and later I will disclose. Okay, I will discuss one method or 2 methods based on the requirement. Okay, and I will discuss whatever the concept or formula required, etc. in detail based on the requirement. Okay, so I hope all of you will attend the upcoming live session series, whatever is going to come regarding the previous year questions regarding communication system subject. Okay, from October 17th onwards in this particular month, right? So thank you everyone. We'll meet you all in that live session.